Hello everyone, welcome back to my channel once again. So today we will be solving this LeetCode problem number 26. Remove duplicates from sorted array. Okay, so given an integer array nums, the name of the array is nums, sorted in non-decreasing order. Non-decreasing order means either it can stay same or it can increase. So staying the same would result into duplicates, right? But it should not decrease. That's why the word non-decreasing order is written here. So remove the duplicates in place. In place means without using any extra space, such that each unique element appears only once, and the relative order of the element should be kept the same. Whatever the relative order is there of the element, it should be kept the same. Like here, see, 1 2 is in a relative order, 1 2 unique elements 1 2 are there, and the relative order 1 comes before 2, so 1 is there and before 2. Here you see it should be 0 1 2 3 4, so relative order should be maintained. And what we need to do is, we need to return is, consider the number of unique element nums to be k. After removing duplicates, return the number of unique elements k. This is expecting us to modify the nums in place such that the duplicates are removed, and how many number of elements are there unique, that value we have to return as the return type of the function, this remove duplicate. So integer it is. So if there are k unique element, we have to return k. The first k elements of nums should contain the unique number in the sorted order. The remaining elements beyond index k minus 1, because if k elements are there, so what will be the last index? It will be k minus 1, because including 0 0 1 2 3 4 and k minus 1, we are including 0, that's why the k minus 1 is the index. So beyond k minus 1, they will ignore, like whatever can be present, we just need to return the k, which is the number of unique elements. So here they have not allowed us to use the extra space, but for the brute force solution, what I am suggesting is, if we are if we are taking this example like 1 1 2, okay, then here this is the test case 1 1 2. Test case can be larger also. This is 1 1 2. For the brute force approach, we are taking extra space, and the optimal solution I will show, which will be using 2 pointers with in place and without any extra space. But first let's discuss the brute force solution. What we will be doing is, we will be using a tree set. Okay, we will be having a tree set. Tree set, what it do is, it first of all, it is a set, so it will only take the unique elements in it. So if we are having this array like 1 1 2, what we will do is, we will insert all the elements in the tree set. So it will be 1, and then 1 again will come after, at this iteration 1 is already present, so no again no 1 will be there. Then 2 will come, so 2 will be there here. Then it is 1 and 2, this is tree set. So the tree set follows the sorted order. While what we will do is, we will start taking the element back from the tree set to the nums. Okay, then this will goes to 1 and this will become 2. Okay, and we will return 2 number of elements which are unique, so we will return 2, and beyond 2 whatever is present, it's not of the concern for this test case. So here what is happening is, big O of n log n is the time complexity, because for n element we are inserting in the tree set, and big O of n is the space complexity, because we are using a tree set in extra space, so that's why space complexity is big O of n. For every element, log n is the time complexity, so n elements are present, so time complexity will be big O of n log n for the brute force, and space complexity will be big O of n. So this is just a rough idea. I will not be implementing the brute force solution. I will be implementing the 2 pointer solution, which will be the optimal solution. So let's discuss on that. Okay. So let me discuss it. So let's take the example as 1 1 2. This is the array. Okay. So what I will do is, I will take 2 pointers. One is the I pointer and another is the j pointer. So I pointer will start at 0 and j pointer will start at 1. This is the initialization conditions. I pointer at 0 and j pointer at 1. Okay. So that now what we'll be doing is we need to remove the duplicate element, so there will be at least one element in the test case. Let's see what is the, yeah, so nums dot length is what, it is 1, so at least one element will be there. Okay, so that's why I equals to 0 I have pointed out, and j equals to 1, so at least one element is there. And then we'll have this one loop while j is less than n. Okay, while j is less than n, what we need to do is we are using the two pointers while j less than n. Now if nums of I is not equals to nums of j, what we'll do is we'll first increment the I, because at the ith position the unique element is present. We'll first increment the I, nums of plus plus I, and then we will assign the value nums of j. Whatever the nums of j is present, we will assign it. Okay, and here what we'll do j plus plus, because we are moving through the array. So if nums of I is equals to nums of j here, then this if condition will not execute. Okay, then what will happen is this only this j pointer will move ahead. But if nums of I, whatever this I is at 0th position, it is not equal to nums of j, then we'll do nums of plus plus I equals to nums of j. And then in the end, what we'll do is, in the end, we will return, because I is the place where the unique element is there. So that indexing wise, it will be 1 minus. So in order to find out the number of elements, it will be I plus 1, number of unique elements. What I am saying is, let's say 1 and 2 is there and I is here. So index wise, I is what? I is 1. But the number of unique elements will be what? They are 2. So I am returning I plus 1 for every case. Okay. So now let's code this up and see what happens. So according to the dry length, first n equals to nums dot length, and int I equals to 0, comma j equals to 1, while j less than n. If nums of I not equals to nums of j, what we'll do is we'll say nums of plus plus I equals to nums of j, and here we'll do j plus plus, and then returning we'll return I plus 1. Let's check the sample test cases whether it's running or not. Yeah, sample test cases are running. Now I will submit and check whether it works finally or not. Yeah, so this is working very fine. And the time complexity is just big O of n. One loop is there, the n times, and space complexity is big O of 1, because these are the only two variables. So for the optimal solution, what is the time complexity? Big O of n, and space complexity big O of 1. So this is the most optimal solution for this problem. Yeah, so that's it for the problem. And yeah, please do subscribe to my channel and like the videos if you are really liking my videos. Yeah, so that's it for the problem.